Hi, I'm Dion from leavingcertmathsvideos.com. Now this question here, question 3, is actually fairly handy enough to do because the first part of it you have complex numbers and the second part of it you have matrices, and both of these questions are actually very easy in the Leaving Cert. So if you get a question with both of these in anymore, I recommend that you do it. Right, to start off with this question here, we have a complex number divided by a complex number. So when you ever have that situation, the best thing to do is multiply above and below with a conjugate denominator. That means basically multiply above and below by 2 plus I. So that's what we'll do. So that is equal to 1 plus 2i times 2 plus I all over 2 minus I times 2 plus I. And that is equal to 1 times 2 is 2 plus I plus 4i minus 2. That is all over 2 2s are 4, minus x plus x cancels out, and then you have minus I squared, which is minus minus 1, which is plus 1, which is 5. So then it means on top you're going to get 5i, and the bottom you're going to get, 4 plus 1. And the bottom you're going to get 1, so that's equal to 5i over I is equal to I. You can rewrite that if you want. So 0 plus I. And that's your answer there. Now, on to the next part of the question here. We have, basically on complex numbers, when you're equating complex numbers, it means one term is equal to another term. That always means that the real parts of the complex number are always the real parts, and the fake parts are equal to the fake parts. So when we multiply this term out, the real terms on the left hand side are going to equal the real terms on the right, and the same with the fake terms. So just multiplying this out here, we have a squared plus 2abi minus b squared is equal to minus 3 plus 4i. And we're going to just put the real together here. So the real terms are a squared minus b squared, and the fake terms are plus 2abi. And that is equal to negative 3 plus 4i. Like this. Now, the real equals the real and the fake equals the fake. So this is the real term here, and this is also the real term here. So they're equal. And then similarly, your imaginary terms, your fake terms are equal here. So then we have to equate them. We start off with our imaginary. So 2ab is equal to 4. That implies 2ab is equal to 4. And divide above and below by 2a, that implies, no, we divide above and below by 2b. That implies a is equal to 4 all over 2b. And a is equal to 2 over b. So now we know a is equal to 2 over b. Right, a is equal to 2 over b. So that means 2 over b, all b squared minus b squared is equal to negative 3. So we're going to work that out now. Let's just step it there. Yeah, 4 over b squared minus b squared is equal to negative 3. Well, we have here we've got b squared in the bottom, so really we have to multiply every term by b squared in order to get rid of the denominator here. So that multiplying by b squared, that implies that 4 minus b to the power of 4 is equal to negative 3b squared. Now, what we can do here is just bring everything over to one side so we get a positive b to the power of 4. So that implies b to the power of 4 minus 3b squared minus 4 is equal to 0. Now, what we'll do here, we'll definitely do for this type of question, we'll just let y equal to b squared. Y equal to b squared. That implies y squared minus 3y minus 4 is equal to 0. So here we have it, y, and in order for this to work we have to have a negative 4 and a positive 3 equal to 0. And extend this down to 4. Now that implies y is equal to b squared, remember that, is equal to 4 or negative 3. So y is equal to 4 or y equals negative 3. So we have y equal to b squared, is equal to b squared. Now we're looking for the real parts here, so we're just going to ignore this question here. So we don't want an I in this term, so y is equal to 4. So that implies b is equal to plus or minus 2. Minus 2. And then at b with plus or minus 2, we have a is equal to 2 over b. A is equal to 2 all over b. Just check that. Yeah. A is equal to 2 all over b. And that implies that when b is equal to plus 2, at b equals plus 2, that implies that a is equal to 1. At b equal to negative 2, that implies a is equal to negative 1. A is equal to negative 1. So then we have our two forms here. It's 1, b is equal to plus 2, 1 plus 2, I, and then we have negative 1, negative 2i. So there are two solutions for that. Now on the next part of the question here, we asked to use what we found before to solve a quadratic equation. Well, I just wrote this up here, just because we need that formula later on. Solve x squared plus x plus, I'll just put that in brackets to see why in a minute. To solve that equation equal to 0. Now, this is a quadratic equation, and what we have to use, the formula here. So we'll just write down the general term underneath. It's ax squared plus bx plus c is equal to 0. Now, we also know that x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. So we'll just write that down here. X is equal to minus b, which is minus 1, plus minus the square root of b squared minus 4ac. And b squared is 1 minus 4ac. 1 minus 4 times a is also 1, and c is 1 minus I, all over 2a, which is 2. So that is equal to minus 1 plus minus the square root of, and we should be looking at something similar of what hint we're given in the question here. So that is 1 minus 4, which is negative 3, and then we have negative 4 times negative I, which is plus 4i. Plus 4i. Yeah, that's the same as we had at the start, and then that's all over 2. So then we know that the root, if we can root both sides here, so if negative 3 plus 4i is equal to 1 plus 2i out of the square root both sides. So that means the square root of this is equal to the square root of that. So that means the square root of this term here is equal to 1 plus 2i. So write that down, 1 plus 2i. Minus 1 plus minus 1 plus 2i all over 2. So then we take the positive. So that's minus 1 plus 1 plus 2i, which is plus 1. Minus 1 plus 2i all over 2. Minus 1 plus 2 is 0 plus 2i over i equals 0 plus I. And then we have our next one here, which is taking a minus. So it's going to be minus 1, minus 1, minus 1, minus 1, minus, between brackets, minus 2i. And that is all over 2, which is negative 2, negative 2i, you can take 2 as a factor, negative 2 into 1 plus I, all over 2. And these will, and then divide by itself as 1. So minus 1 minus I is your next solution. Minus 1 minus I. So there are your two solutions. Minus 1 minus I and 0 plus I.